Thank you. Okay, so I'm going to talk to you all about an iOS game I built and kind of show you a little bit about building games and a couple maybe iOS-specific stuff, but hopefully you can learn from that and you can build on any platform. So quick show of hands, who here has worked on a game before? Anyone? Okay, awesome. Lots of people. Sweet. Okay, so I'm going to close. Well, actually, first thing I'll do is I will show you the trailer for the game so you can see what it's about. I'll just play that real quick. I don't know if there's, well, I'm muted, but you can see the game. So you drag your ship around, and then what happens is the enemy ship will copy what you do. So you basically fight mirror images of yourself, and you tap to shoot bullets and try not to get hit. So y'all can see. And then after you win a few times, you get a weapon upgrade, make it a little more interesting. It makes it easier for you. It also makes it tougher the next waves because they have similar weapon upgrades. Yeah. Oh, sorry. Yeah. Sorry. Sorry about that, guys. Apparently I closed the Hangout window. Truly. Okay. Share the screen. Okay, sorry about that. Close browser. Okay. Yep. A little more of copying yourself. Okay. Can you see okay? Okay. So, yeah, resuming. Just keep playing where it's at. Yeah, in this one, the bullets go sideways instead of straight up, so you gotta kind of dodge around. Yeah, so it's pretty much the game. Add in there's a company called Camcord, which provides a free replay for iOS, which is really awesome. So you can record replays and share them. It was a lot easier to get this working than to do screen captures and turn those into a GIF or something. And I say a lot easier as in it worked literally in a few minutes of setting up and getting. When you try to capture screens on the iOS, it actually gets very high resolution, and editing is kind of annoying. So I just went with that. Okay, so let's jump in and show y'all some code. So it seems like a lot of y'all have built games before. But for those who haven't, those who haven't. If you're familiar with a REPL, anyone? Read, evaluate, print loop? So, yep, someone. So that's basically what you want to do with a game. You want to get player input in, you evaluate it and do some logic with it. You print it out, usually in the form of audio and video on the screen, and then you keep looping. You just keep doing that. So pretty much the first thing I like to do when building a game is put something on screen and then have the player interact with it somehow. So I kind of go to the print thing first, like can I draw a box or can I change the background color or something? And then, okay, I press a button and it does something. So I'm using a framework called Cocos 2D. And Cocos 2D is available in many languages. It's in JavaScript, it's in C#, it's in Objective-C, it's in Swift now. It's in Python, I believe. It's basically a game framework for making 2D games, and it comes with built in with support for Box2D, which is a physics engine. I'm not using Box2D, but it's, from what I've seen, easy to use, and there's been several actually really successful games that use Box2D. It's just sort of a plug-in physics engine. So FY, if you're into making 2D games, it'll make your life easier, definitely. So this is some Cocos2D setup. I'm going to kind of just scroll past this because it's just simple config stuff. What's that?
What is app portable?
App portable. Where is that?
Right there. If that.
Oh, you know, I don't know, actually. It looks like, I'm going to guess, because that's checking, well, you know what, I don't know. I really just copy and pasted the config stuff and then tweaked it a bit, so yeah. This needs to happen before screen scale factor, yeah. I don't know. So Cocos2D sits on top of OpenGL, which is Open Graphics Library, which is pretty much the standard for how you want to draw stuff, or at least it's been a standard for a while for drawing things. So you can see a couple things do here. This GL disable, GL blend, this is to disable blending. So if you have like two pixels on top of each other that are different colors, it doesn't blend them together. This is for performance reasons. It takes some processing time to do that effect, and I wanted the game to run as fast as possible. So I disabled that. And then this color mask as well. So that's red, green, blue, and alpha. So I'm just saying, hey, there's no alpha. So all colors are either there or they're not, again, for blending reasons, just to optimize that. And then the last thing for performance is this CC config pixel format. There's a color format here. Can y'all see the text okay? Is it? Okay, good. I bumped the font up. Just let me know if you can't see it.
Whatever you're highlighting, scroll up.
Yeah, sure. Yeah. So that this here, there's a few different formats. This one has less colors, basically. So there's less colors available, which improves performance a bit. So just a couple small things, but that'll, I did find that made the game run a little bit smoother when testing on older hardware. So stuff to keep in mind as you're developing a game. You know, it's always nice to push the performance and make things look really pretty or show off your cool graphics code, and then you have someone who has, you know, a lousy graphics card or an old device, and you're like, oh, it doesn't work at all, or it runs real slow, and that's no fun. There's my camcorder developer key if, if you want to get that. So, yeah, Cocos2D, you load a scene. In this case, there's a main scene, and I'll just hop over there. And so what I've done is, so scene is how Cocos2D organizes its events, and you can have there's a director which loads the scene. Funny terminology. And the scene is actually a CC node, and it's inherits from CC node, and a node is something you can draw on the screen, which is great. So I have a class called a battlefield, and this is sort of my view controller. It's what you see, and it's also got the foundation for the logic of the game. The view controller paradigm, for those of you familiar with MVC or model view controller, a lot of stuff on mobile tends to follow sort of view controller pattern, which might sound a little strange, maybe if you're coming from the web a lot, but it ends up working pretty well. Yeah, it's a little bit coupled, but it's kind of nice because you can see all your logic in one space. So, okay, this is the code, and I know I'm going to see this code be executed when I'm on this screen. Great. So I created Battlefield. I add it as a child, so it will be visible. Very important, this line, user interaction enabled. Nodes are by default not enabled for user interaction. Also, in iOS development, the UI view, the base class for drawing a rectangle, anything on the screen, not user interaction enabled. So if you're trying to tap on an image or something and it's not working, check that flag. And then I just record the size of the screen, just so I don't keep calling that method. So pretty much all this does is sets up a battlefield, adds it, and then I'm going to catch the touch events. Touch began, touch moved, and touch ended. So when you touch down, when you move on the screen, and when you let go. And you will notice that there's some weird stuff happening with screen height minus L.Y and stuff. That's because OpenGL and iPhone use opposite graphs for their XY coordinate system. Which is kind of goofy, but what I do is I just check the events right from the beginning and flip them. And so whenever it comes in my game, I don't have to worry about, is it on, up or down or whatever. So just something, again, if you ever find yourself coding and you're like, wow, why is everything backwards from where it is, and you're using OpenGL, that's probably why. OK, so I'll just jump into the Battlefield class. And it's about 100 lines in the header. And it starts up in the init. And I like to get a little fancy with my method name. So you enter the pilot. That just creates a pilot. A quantum pilot, actually, is the name of the class. And it adds it and resets position. And there's just some setup stuff. This schedule command, that is used by Cox2D to do a timer. So I'm scheduling, and I'm aiming for about 60 frames a second, which is pretty smooth for the icing. Now, you may have heard rumors that people can't actually see anything beyond 60 frames a second. That's a lie. You can test it yourself with grab an old version of Quake or something and test it. You can proceed more than 60 seconds. Personally, I've seen games run at 120 and go, wow, like that's really smooth, and then drops it down to 90 and 60, like, okay, it's off. But when you start getting below 60, especially if it sort of jitters, that's what'll throw you off a lot. And for anyone who's done any virtual reality work, you may have heard that people can get motion sick if the frame rate jitters. So 60 frames seems reasonable. I could try to push it, but again, if I'm maxing out and then it stutters, that's no fun. Now, something about timing in game programming that's real-time, with real-time events happening. A lot of this game is actually run sort of step by step, so I'm not using delta time. And what delta time is it's an algorithm for checking that you don't, you're drawing the screen at one rate and you've got your game logic on update. Generally speaking, most hardwares can render, they're going to render slower than they update the logic. So your logic might be flying through and doing a bunch of physics calculations and floating point calculations, but if you're sort of stuck at a rendering spot, then the game might slow down if you tie that together. So the way you get around that is you do delta time, and so every time your function gets called, like your loop function, the engine will give you a delta time, which is time since the last time it called that. And then you check, and if your delta time exceeds a certain threshold that you set, that you choose, then you say, oh, I guess I'm past 1/60th of a second, I should go ahead and draw on the screen. And that's a really good way to write games, by the way, and I strongly recommend it. I don't do that here. And the reason is that this game was much easier. It was originally designed as and much easier to develop if I thought of things as happening frame by frame. And while I'm confident I could have figured out how to make delta time work with it, and I've sort of brainstormed a bit, I really didn't want to bother. So I made some optimizations. I tested the frame rate. I had some tests where I would hold my finger on the screen and hundreds of bullets would shoot, and the frame rate, would stay around 60 or 59.9. I went, oh, that looks pretty good. Okay. So that's a little about timing. So that's some information about delta time. That's why I didn't do it here. Set of elements. This just sort of, I've got some arrays for bullets, pilot bullets. Those are in separate arrays because I basically check, do your bullets hit the ships and do the ship bullets hit you? So it's just easier to have them in a separate array. There's clones, which are the enemy ships. Shatters are this little, when you hit a ship, it sort of pops, and it's a different special effect. So instead of having that be like part of the ship, I just remove the ship when it's done, and I make another class called a shader, which can handle itself for drawing. The path carver is what you see when you touch the screen and it draws a path to show you what you're seeing. The clone carver basically mirrors the path carver, and it shows you in red and reverse on the top of the screen. So if you draw right, it's going to draw right. And in red, that's going to show you what the clone does the next time around. Now for some interesting, there's some sound stuff, which, yeah, I make a AV audio session and mix with others. That lets you listen to your own music while you play. There's other audio categories if you want, like your app to play music in the background or something, which is fun, but not needed here. Oh yeah, and then there's the deadline, which I think you saw in the video. There's a red line that comes down, and that kills you, so it's basically a time limit. And yeah, so we're some kind of interesting code here. This stage and state. This took me a while to figure out, and this is, I think, the 5th version of the game that I've written as far as code bases go. I started a while back and wrote and added stuff to it and had ideas for features and added stuff and deleted stuff and kept rewriting it. That might sound like a real pain. Honestly, it was really good to just rewrite each time and restart, because I sort of would try a few things and then say, okay, that didn't work from a game design perspective, but maybe that one thing was cool. I'm going to pull that out and start over again. And I got some better design, better code design. And honestly, I could sit down right now and rewrite this thing just sitting here typing if I wanted to, which I think is a good sign that I've really internalized the concepts and I'm not sort of stuck to the code base, and I could go build another game with similar principles. I think that's an important place to get to if you're working on a project, especially a game like this, that you sort of understand it in your head and it's not spread out along so many classes you forget what they all do, and you know, I don't know, I'll check the comments. You don't want to be there. Okay, so stage and state. So what this is here is there's really only a few states, and get to subclasses. There's the combat state and the draw state. And the draw state is when you're touching the screen and you're moving around drawing, and the combat state is when you're not and the game is happening. In earlier versions, there was, I want to do things like maybe buy power-ups or show the score, calculate your score and all that. But I realized that the sort of input was sort of separate from the progression of the game. So state really just handles, like, are you inputting or not? And stage is how the game's progressing. So there are several stages, 7 of them. There's a start stage, which is at the beginning. There's a new core stage, which is there's a new weapon to pick up. There is a spawn imprint, I believe. Yep, which is that very first clone that you see. And then there's some stages for, let's see, fighting, rewinding, which you want, and you sort of, that line comes down and doesn't kill you and just brings you back to the start. And then core crushed, you got hit, unfortunate, how to deal with that. So splitting these up into different stages and separating that from the state, sort of the input state, was honestly one of the best decisions I made. I figured out after 5 iterations to do. And I'll show you why it works so well. So back in the battlefield, the game loop, which if you've worked on a game before, or you might be thinking, wow, I bet there's a bunch of stuff in the game loop that handles all this kind of stuff, input, moving the ships, all those things, it's actually really a small function. There are 5 lines. That's it. That's all it does. It tells the stage to loop. It tells the state to loop. It tells the path carver that you're drawing to loop. There's a pause filter. The pause filter, maybe I could show it. Well, as you hold down the screen, it sort of fades red. Some playtesters were saying they didn't realize it paused when they touched down, so I added that, and they seem like, oh, it's changing. Oh, the game's not moving. Cool. And the dash carver, which I believe is, that's the little dotted lines that shows the dash to say, hey, go pick up this weapon. So a really small function. And I really like this because if I say had looked at this for a while, or say I hired someone to work on this and say, hey, let's work on this project, and you look at the core loop and it's just 5 lines, that's a great place to start instead of 100 lines or 1,000 lines. God help you. And I've been there and done that, so no problem with it. But yeah, so these the state just has these add, move, and in touch. There's a quick reference to get the pilot loops. And so if we look at like the draw state, this records your origin, and when you move touch, it moves your destination. So you touch down, that's the origin, and now you're moving a destination. And then as it loops, it gets a delta, subtracts your origin from the destination, and tells the battlefield, which is self.f. I know some people hate shortcuts. I had to write battlefield so many times, I just call it the F for the field, and it's just a lot easier. And it says, hey, plot course from this delta, and then it makes the new origin the current destination. So, if I'm here, right, that's origin, and if I stay here for a frame, the destination is going to be the same. So it's going to tell the battlefield, hey, they're the same point. So it'll plot the course not moving. And then if I move over here, it's going to say, oh, your destination is over there. And then once it does that, it resets the origin to this point. So now it tries to move from there. The reason it does that is to make it easier for the player to move around. Phones are small. The screen's not very big, especially if you're used to playing games on a controller or like a big touchscreen. So instead of having you like touch the ship and drag it, you can touch anywhere on the screen and just swipe your finger around, which I think is a great control scheme. And I find games a lot easier to play when they do stuff like that. You may have seen some games that will put a little virtual joystick you have to like hold your finger on, which is not tactile, so it doesn't work. And it's really annoying when your hand wants to move, or you're on the bus and the bus jolts and your thumb moves and then you die. You're like, oh damn, if I could have just tapped anywhere, it would have been fine. And so that's what that handles. And plot course from delta just tells the path carver to figure this out. And there's some waypoint code here. So it gets the latest waypoint, and it makes sure we're under the path limit, so we don't run out of memory. I picked a sort of arbitrary number, but yeah, it's also based on, I figured out how long you have the game to play for the deadline to come down, just put that many frames. So what I first check is I make sure this width -9, height -28. So, and those probably could be constants on the ship. Oh well. That is making sure that you can't draw off the screen, because if you draw your finger off to the edge, the ship will go there, and then your ship might disappear, which is really awkward. And first time I saw playtest paths, I'm like, oh my god, my ship's gone. Okay. So that's just a check to make sure that the new point, you can see what it does here. I get the latest as the latest waypoint, and then I get the delta that came in when I dragged, and it calculated the delta, and I add it, and it just makes sure it's within sort of a bounding box. And once it does that, I've got an array of points, and I have this integer called waypoints drawn, and I set the future waypoints of index waypoints drawn equals to the new point. And then I increment waypoints drawn. And so this is useful because it means that if a player taps here and then just starts zigzagging like crazy, that's okay. It'll just record as many points, but the player might, the ship's going to move a lot slower than they moved. And that's where this waypoints reach comes into play. So waypoints, every time the ship gets close to a waypoint, you reach the waypoint, increment that, go to the next one. And yes, this assigns pilot movement. If waypoints reach exceeds waypoints drawn, you've reached the end of your waypoints, stop moving. So in this case, I just set the pilot velocity to 0, so 0, 0. Otherwise, assign velocity for next waypoint. And there I get the waypoint. I figure out a distance to the target from the pilot's position to the waypoint. Get angle, I know it's not a true angle. I wrote this function like 6 years ago, and it basically, get angle does a x, y difference. So it's going to be range from -1, comma -1 to 1, 1. So it's just the vector of it. I know it's not the proper term, but I reuse code and it works. I check if the target's further than the speed, and if it is, assign velocity for target outside the range. Otherwise, assign velocity for target within range. Outside range, it just, velocity is the pilot's velocity times the speed. Pretty simple. Otherwise, within range, it's where is it? Yeah, if it's greater than 1, then cap it. So just make sure the pilot's not zooming out after the waypoints. So yeah, so this is all in the path carver class, and you see it's a decent chunk of code. There's about 120 lines in here, and that's all related to just figuring out how the ship moves. So very important when you're writing games to separate your concerns, and honestly do it earlier than you think is necessary. I'm gonna say this again: do it earlier than you think is necessary. Or, and it's not so bad, but you'll end up rewriting it a bunch. But if you can sort of like, oh, this is a concept related to moving the ship, just put that in its own class, and just makes it a lot easier to manage. Okay, so back out a bit, we go. Oh yeah, so that's all in the draw state. And when you end the touch, show pause 0, false. So remove the pause filter. Tell the battlefield to, and I'll add some lines so I'll see that. Remove the pause filter, shift to the combat state, and increase multiplier on the score to 0. That's just some code. I've got a score thing that shows your code, shows your multiplier up top. I'm saying increase by 0. That code is actually going to trigger some display logic to show your current multiplier when it gets increased. So I'd say up it by 0, and it'll show. So shift to combat state. That just assigns state. State becomes combat state. So pretty straightforward. And the combat state has it's a little more complicated. We've got here is, in this case, when you add touch, it says you're holding the screen and set the touch to whatever your position. If you move the touch, it checks if the new point that's being passed in is beyond 8 pixels away from where you touch down. And if so, then we're going to mark drawing as true. And in the loop, if drawing is true, then begin drawing from, and that is just going to trigger back into the drawing state with the original point in the destination you pressed on. So you're fighting and you touch down, you move, it's going to start drawing. Why is it 8 pixels? Well, people don't have perfect neuromuscular control. So when someone touches down the screen, their finger's going to wiggle a little bit. And it's really annoying if they're just trying to hold still and their finger ups 1 pixel. And the game's like, you're drawing. And no, they're not. They're just trying to hold down. So I just played with that value until I got to 8, and that seemed to work pretty well. And people stopped complaining about it. I said, okay, that's good. And then should fire, so I'll go through the loop here. So if you're holding down, increase the held counter. And if held exceeds 10 frames, then tell the pilot to fire. So this is auto fire, basically. Normally you tap to fire. It took me a while to really notice this, but a lot of people kept trying to press and hold, or like, I want to shoot, or why isn't it shooting? So if you just hold down, it's just going to fire away. So I think it's good to always give your users different options on how to achieve things. Now, you might have a good flow to guide them through your web app or your game or whatever. But if you see people are really keep trying to do things one way, consider, hey, giving them an avenue to get to accomplish that. Yeah, so that's pretty much the loop there. If it's drawing, then switch to the draw state. Otherwise, just otherwise shoot. And then when you in the touch, if you should fire, then fire and then cancel that that you're holding on. So you can just sort of like tap and it'll shoot as well. So that's pretty much it for the combat state. So there's drawing state and combat state, two main states of the game. So I'll go into the, so start stage, or actually, yeah, start stage is it. So this is some new game stuff. Play a little sound effect. I wait half a second and then spawn the core, so it's sort of, there's a little zoop, and the pilot shows up, and spawn core gets called on the battlefield, which calls the new core stage. And the new core stage has, it resets the deadline, so gets the deadline back. I try to authenticate local player. That's related to high score stuff. I just kind of get that out of the way because there can be some callback time. I clear out the clones display, their red line. This might look kind of funny. So the leveler, which I know is, I was having fun with the class names. That is there's a little pop-up that can show you a link to Replay and Game Center and a link to my website. Well, I really wanted people to focus on the games. That only pops up if there's 4 clones or greater, because I find it really annoying to play a game and the first thing they do, sometimes even before you start the game, is like, hey, like us on Facebook, click here to check out more stuff or buy a site. I don't want to deal with that. So only if people have actually played and gotten the hang of it a little bit, then it starts like, oh, cool, I can check out my high score. That's neat. And then this does checks what the weapon level is from the battlefield and gets some sounds. And you can hear me saying the name of the weapon, which is really fun. So wave. Let's try it here. I don't know if there's sound maybe for the audience on the internet. There you go. So, yeah. And there's just some logic for collecting the core, which is going to check assign your weapon. You get a multiplier bonus, and show the score if you've got any kills. If you don't have any kills, it means you're starting the game, so you don't need to show points. How are we on time, by the way? Where's our?
We got like 10 minutes still.
Okay, cool. So I'll jump through some stuff then. So I'll go ahead and show some stuff here. So weapon. No, it was core. Yeah. So a core is that circle you pick up for weapon, and I've got a base class, and then I've subclassed with these different weapons, and they all have a bullets for location function, which they're going to all play a sound and then spawn some bullets, and that's going to return an array which sends back to the battlefield, which is it's nice to sort of separate those out again instead of having like one big if statement to check. And then inside those bullets, sometimes they have special logic, like this slicer. What it does is it has, that's the one where it goes like that, does kind of a sine wave. So inside of its loop, or its pulse here, I figure out if it should turn, and then pulse, oscillate, and if it should turn, then reset the turning, so it's going to go like out, and a timer is going to expire, and it's going to keep doing that. And then there's some other bullets like the melter. It's got a X draw rate for how it might be angled like this or like this. It's one that shoots 2 here and 2 here. So yeah, you can just really sort of customize your effects by making separate classes for them, and then you can run the logic in there. And let's back out. Oh, so I'll just run to the combat, or the fight stage. This is where, you see there's about 200 lines logic here. This is where a lot of the fighting, where all the fighting logic happens. So I'll just run to the loop. Yep, so bullet loop, going to loop through and loop through all the bullets, see if the pilot overlaps any of them. If it does, the phone vibrates. That's Audio Services Play System Sound 1352. For some reason, the constant for that didn't work, and then someone on Stack Overflow figured out the magic number, and it works. So cool. I don't know. I tried the constant, and it doesn't vibrate.
Magic numbers for the win.
Yeah. And after you get hit, I delay 2 seconds and tell Camcord to stop recording, and then go to the core crush stage because you died. Same with the deadline loop. The deadline's going to pulse, and it just keeps moving down. And if it passes the pilot's position on the Y, trigger again 2 seconds to stop recording. So it doesn't stop recording immediately. It just, okay, oh damn, I got hit, and then it stops. You can see the aftermath. And the deadline also, I check, it checks all the clones. When it passes them, they turn red. It looks a little sinister, and hopefully gives some urgency to it. So there's the deadline loop, bullet loop, and the clone loop's really simple. The super clone loop just is going to tell each clone, hey, move. And then if kills equals 0, then you won. So I know we're running low on time, so I'll just run and show you all something that's kind of unique to the game. And that is, let me see, where are we at? Yep, record. Find this. So the pilot class has a spawn clone function, which will create a clone and make a copy of the current weapon it's got. And then it's going to loop through its current iteration, how many frames it's gone. If you remember when I talked about delta time, it's a lot easier to just like run through a bunch of frames instead of figuring out, oh, you moved this far on 1.53 seconds or something. Nah, just 2 frames. And it tells the clone to record your vectors from that index, and did you fire or not at that index. So every time you move, it's just recording where you move to and recording the delta of that. And that delta, let's say the delta is like, it's straight right, so it's +1 comma 0, right? That sends to a class that handles the waypoint and says, okay, the current waypoint is right here, go +1. This is a big grid, right? So go +1 here. And the next one is another +1 here. So then when it plays back, it's going to say, okay, I'm over here. I got to find my first waypoint. Okay, now I'm going to move till I hit this one, and then move till I hit that one.
Do you do the attempt to like filter or identify the user's intent in this motion, or you just go
No.
exactly?
Nope.
I don't work on games.
Yeah, so I know that there is some. I actually don't know if it's happening here or not. I know that there's a class on iOS that does do some smoothing for you automatically if you do that. In this case, I don't think it's happening, so I'm just capturing the differences in points, point by point. And the user sees an exact line, so if it's not what they intended, they can just redraw it real quick.
Oh, I see.
Yeah. Yeah.
I should have played, so sorry if you already talked about it, but what do you do for sound assets?
Yeah, that's a great question. I use this tool called CFXR. Well, you probably can hear if that's making little explosion sounds or laser sounds. CFXR, formerly known as BFXR, it makes 8-bit, 16-bit game sounds. And then I hired a musician. Actually, they reached out to me on the indie game forums and said, hey, your game looks cool. Do you want to hire me to make some music? And I checked out their work, and I said yes. And they're fracturesmusic.com if you need to hire a good musician. Any other questions? No? Okay, I've got one more thing. Thank you. I've got one more thing to show real quick. Thank you. Thank you. So I've got one more thing to show real quick. This is, I made an open source JavaScript framework for recording things. So you can, if you check this out, it's Quantum Potato Quantum Imprint. And it'll let you, well, let me just run it real quick. Oh. Live demo. So it moves around and it paints, and then you click, and then it records that, and you can keep doing that. And it'll keep going. It looks really messy. But it's sort of a good proof of concept, like, hey, you can record things and play them back. So if you're interested in that sort of logic, you can check it out. And if you can read JavaScript, go for it. So yeah, it's really small. It's like, yeah, 40 lines of code to do that. So have a look. Quantum Imprint.
All right.
All right, thanks, y'all.